I'm Anil Kumar, and now let's begin to understand what is sum and difference of functions. Now this particular example is a very good application question, and from here we will see how combination of functions work. The question here is, student council is selling t-shirts to raise money. There is a fixed cost of $4.50 for producing the t-shirt plus a variable cost of $3 per shirt made. Council has decided to sell the t-shirt for $8 each. Now from that particular scenario we can write couple of functions, and we will see how to add and subtract these functions and then understand combination of functions from there. Now when we say student council is selling t-shirts to raise money, that means there will be some revenue from that money, right? There is a fixed cost, we're talking about cost for producing t-shirts plus a variable cost which is $3 per shirt, and we have a selling price which is $8. So from here let us first find the cost function, right? So we'll find the cost function first. Now cost of producing a t-shirt is fixed cost. Let's call this as C of X, where X is the number of t-shirts produced, right? So in that case it is fixed cost, which is $450 plus $3 per shirt made, so it is 3x. So that becomes the cost function. And now let us also find that what is the revenue. Council has decided to sell t-shirts for $8 each, so the revenue will be $8 on each shirt. So we can say revenue is 8x. Okay, so these are two functions for us. Combining these two functions, we can actually find the profit function, right? So R of x equals to 8x is the revenue function. Now we can combine these two functions and get profit. Now what is profit? Profit function is difference of revenue and cost, right? So we have let profit function be P of x, that is equals to revenue take away cost, that is the profit. Now here we know revenue is 8x, so we have 8x minus cost is 450 plus 3x. So that becomes the profit function. But by doing so, we have done combination of functions. This is what we are going to discuss in this chapter, combination of functions. We can simplify this, right? 8x minus 3x is 5x. We get 5x minus 450. Now with this, we can actually solve many related real life situation problems. Now in this particular case, what we can do is we can sketch graph of revenue and cost function and then figure out when are we going to get some profit, right? We can find that profit algebraically or graphically also. Okay, if you are doing it algebraically, let's do it algebraically first. Let's do a algebraic solution for finding break-even point, for example, right? Now break-even point is a point where profit is equals to 0. That means we have taken care of all the cost at that point, right? Anything produced beyond that is going to give us some profit. That is the whole idea. Now break-even point, as we are defining, is when the profit is 0. So at break-even point profit is 0, so we can substitute 0 here and solve. So we get 0 equals to 5x minus 450, or we can say 5x equals to 450, or x is equals to 450 divided by 5, that is 90, right? So that means once 90 t-shirts are sold, we have taken care of all our cost and we are break even, right? Revenue and cost is exactly same at the point when 90 t-shirts have been sold, right? So that is what we can get. Now as you can see here, we have combined functions to solve a real life situation. Now we can also find solution graphically for the same function. Let us sketch the function c of x, which is 450 plus 3x. Let us say this is 450 in dollars, and that's the rate 3x. So let's say this is graph which represents the cost function. Let me call this as cost function, c of x, and let us say this is 450, and the slope is of 3, right, per sure. Okay. Now revenue function is 8 times x. So if that is the graph for the cost function, then revenue, when nothing is sold, there's zero revenue. So it will be kind of steeper than this. This is plus 3x, right? Revenue is 8x, steeper than this. So let it be like this, right? So this represents for us a revenue function, r of x. At the point where it intersects, what does this point signify? What does this point signify? It signifies the break-even point. Do you understand why? Because at this point, the profit is zero. Before this point, the profit is negative. We are making loss. You get the idea, right? So, if you sketch the profit function, which is revenue minus cost, then to start with, when nothing has been sold, we are at a loss of 450. That is minus 450. Do you get the point, right? But as soon as you make revenue same as the cost, the profit becomes zero, or we call this as a break-even point, and that is the graph for the profit function. You get the idea, right? Now, it's kind of an approximate diagram, so but you get the idea as to this is, we are saying this is a profit function, right? So just when revenue is equals to cost, we have zero. I should not write zero. This is 90, we know. Where this is x, x is the number of t-shirts sold. Those are amounts in dollars, right? At that time, we are not making any loss. So this is the break-even point. This is the break-even point. Now profit, loss, cost, revenue, demand, these are good examples of combination of functions, right, as discussed earlier also. So we'll do a few examples and then get conversant with sum and difference of functions. I hope that helps. Thank you and all the best.